So we're going to talk about compound interest. Compound interest is the interest paid on the principal, usually on loans or investments, plus all other accumulated interests in all payment periods. The principal is oftentimes called the present value, and when the interest gained is added to the principal, we obtain the future value. When compounding is done only once in a year, we use the formula A is equal to P the quantity 1 plus R raised to the power of T. But this formula sets a restriction when we compute for the interest that is compounded more than once a year. This is called periodic compound interest. When compounding is done more than once a year, the compounding period may be semi-annually, quarterly, or monthly. We then use the formula A equals P the quantity 1 plus R over N to the power of NT in computing the future value of a given principal or present value. The formula has the following components. A stands for the future value, sometimes called the accumulated value. P is for the principal, or sometimes called the present value. R is the rate of interest, called the nominal rate, and N is the compounding period or the conversion period, and T is the time, usually indicated in years. Interests can also be compounded continuously, and here we use the formula A is equal to P the quantity E raised to the power of RT, where this E is equivalent to 2.71828 and it's called the Euler's number when we compute the future value. The present value or the principal P is invested at an annual interest rate in T years. So here are the components of our formula. A is the future value, P is the present value, and of course E is our Euler's notation, Euler's number. R stands for the rate, that is the rate of interest, and T is the time. Let us now go over some problems involving compound interest. This is the first problem. Suppose you deposited 10,000 in the bank at an annual interest rate of 2.4% compounded annually. The question is, how much will your deposit become in 8 years? So let's take our solution here. So it is obvious that our 10,000 pesos represents the principal or the present value. The rate is given as 2.4%, or that is 0.024 in decimal, and T is 8 years. And we're going to look for A because it asks how much will the money become in 8 years. So that means to say this is already the accumulated amount. That is, the principal and the interest have already been added together. So finding the future value, we will be using the formula A is equal to P, the quantity 1 plus R raised to the power of T. By substitution, we have 10,000 multiplied by 1 plus 0.024. That's going to be raised to the power of 8. Take note that we have to simplify first 1 plus 0.024 before we raise that to the power of 8, and eventually to be multiplied by 10,000. You may input that on your calculators directly, and we have an amount 12,089 pesos and 26 centavos. That is the amount accumulated from adding the deposited 10,000 pesos and the gained interest. If you would want to find for the interest, you may just simply subtract the 10,000 peso deposit from that accumulated value or future value, which is 12,089 pesos and 26 centavos. And this is going to be our future value. The second example is that what is the present value of 25,000 due in 15 years if it is compounded at 7.5% quarterly? So in this case, we're going to make use of the formula applicable to periodic compounding. So this is going to be our solution. The first thing is we have to identify the given data. The 25,000 there is of course the accumulated value because we are going to look for the present value. R is 7.5, which is 0.075 in decimal form. T is 15 years and the compounding period is quarterly. And so we're going to find for the unknown present value. Finding for the present value, we use the formula P is equal to A divided by the quantity 1 plus R over N raised to the power of NT. This has been derived from the original formula, which is A is equal to P the quantity 1 plus R over N raised to the NT. We simply divide both sides by that given expression 1 plus R over N raised to the power of NT. And so cancelling this out, we have P is left to the right of the equation. And so we have P is equal to A all over 1 plus R over N raised to the NT power. An alternative solution for that is when we make use of negative exponent. And so multiplying A to that expression 1 plus R to the N raised to the negative NT power. And so by substitution, we now try to substitute all the given to this formula, where A is 25,000, the rate is 0.075, N is 4, and then NT will be 4 times 15. And then this is going to be 25,000 divided by the simplified value of the denominator is 3.0483, and eventually that is equal to 8,201 pesos and 30 centavos, and that is going to be our present value. For number 3 example, how much is the interest if 5,500 is invested at 8% compounded semi-annually for 5 years and 6 months? So in this case, we are looking for the interest, but we don't have direct formula in order for us to find out how much the interest is. And so what we need to do is first to find for the future value. And so the given are the following. 5,500 represents the present value P. R is 8%, or that is 0.08 in decimal. 5.5 years for our time, and N is semi-annually, therefore it's equal to 2. And so we look for I, and at the same time we also look for A. But we cannot find I unless we are able to find A first. Finding for the future value, we use the formula A is equal to P quantity 1 plus R over N raised to the power of NT. And so substituting this formula with our given 5,500 times 1 plus 0.08 over 2 raised to the power of 2 times 5.5. And that's actually equal to 11, as we all know. This is a more simplified step. 5,500 times 1.04 raised to the 11th power. And eventually, by simplifying that further, we have 8,467 pesos as our future value. And then from this future value, we now subtract our present value 5,500 to get the interest. And so now we look for our interests. We use the formula I is equal to A minus B, where A is already obtained as 8,467. Then we subtract the given present value, which is 5,500, and we obtain the interest that is equal to 2,967. So that's how we are going to find for the interest, and so that's how we find for the interest in this given problem. We now proceed to this fourth problem. How long will it take 40,000 to become 313 pesos if it is compounded monthly at 6.5 interest? So it is obvious here that we are going to look for the unknown time. The present value, or P, is 40,000 pesos. Of course, it should be less than our future value, which is 55,313 pesos. Then we have the rate is 6.5%, or in decimal that is 0.065. And N is going to be 12 because it says here the compounding period is monthly. and we look for t. The formula that we will be using here is a little complicated than the previous formulas. It already has the application of logarithms, where t is equal to the quotient of the log of a over p divided by the product of n times the log of 1 plus r over n. Here we just simply have to substitute all those given so that inputting this in your calculator, we could already be able to find an exact value for the unknown time. So by substitution, we have the logarithm of 55,313 over 4,000. And then all over 12 times the logarithm of the expression 1 plus 0.065 over 12. Maybe we could have a little simplified value, which is 0.140767 over 0.028153. And from there we have t is equal to 5 years. That is rounded off to the nearest whole number. Time is 5 years. I wish to show how we were able to derive this formula from the original formula for future value, which is a is equal to p, the quantity 1 plus r over n raised to the nt. So here, just as usual, we divide both sides by p, so that what remains in the right side of the equation is the quantity 1 plus r over n raised to the power of nt, while on the left we have a over p. From there, we apply the concept of logarithms. We find for the logarithms of both sides. By our exponential logarithmic property, we now multiply your nt, the log of the expression 1 plus r over n, and that is equal to log of a over p on the left side of the equation. Remember that we're going to look for t here, so it's just proper that we divide both sides of the equation by n times the logarithm of 1 plus r over n, and by doing so, we will be able to cancel n and also that expression log of 1 plus r over n, leaving t, which is equal to the left side of the equation, log of a over p divided by n times the log of 1 plus r over n, and that is equal to your t. And so that's how we were able to derive the formula in finding for the unknown time. So we are now in the last example, number 5. An investor invests $1,000 in a 5-year term deposit that pays a continuous compounded interest of 6%. How much does he receive at the end of the term? It is obvious that we will be using the continuous compound interest in this case. And so we try first to go over the data which are given in our problem. Of course, that 1,000 will be representing the present value, and your r is 6% or 0.06 in decimal. Time is 5 years. And it says here, since the problem speaks about continuous compounding, the formula that will be used is a is equal to p, the quantity e raised to the rt power. Solving for a is equal to 1,000 times e raised to the power of the product of 0.06 times 5. That actually is equal to 1,000 e raised to the 0.30 power. You may just simply input all this given on your calculators and it will give us a specific amount, which is $1,349.86, which actually answers our problem. How much would he receive at the end of the term, of the 5-year term? At the end of the 5-year term. And this is the future value. Thank you.